All right, so there we go. There's the matrix. Two matrices. All right. What are these boxes with numbers in them? They're called matrices. Why are we doing them? Did they just make these up and just put boxes with numbers in them? Yeah, remember? All of math is made up. That's exactly what happened. Why'd they do it? They had some need. You guys have Google with you? You could let me know. I remember I'm a wannabe. I always like history. So I think if I remember right, 1700s, 1800s, there was some need. I think they were mixing things. I can't remember what it was. It might have been like beer or something, and the right mix of something at some warehouse, and they were trying to figure out some formula. And anyway, some time in I think it was 1800s, they were doing something in the real world, and they needed a lot of numbers in boxes. They thought that would be an easy way to do whatever they're trying to do. So they made up these things called matrices. If you want to type into Google and let me know the specific details, that'd be great. Otherwise, I'll just keep moving ahead here. So let me know if you find something out you want to share. But anyway, I'll show you the rules. So basically, at some point, because of a real-life need of things in the real world, they made up these matrices. And they said, hey, what if we just put like boxes of numbers called matrices? And so whenever you make up something new in math, you have to make up the rules for how you add them, subtract them, multiply them, and divide them. So let's do that. Let's make up some rules for how do you add two matrices. Or this one they want us to subtract, don't they? Mm-hmm. They want us to take matrix A and subtract matrix B. Now there's different ways to make up the rules. And we'll see that, especially when we get to multiplying. They'll do that in a totally strange way. If it was up to you, how would you make up the rule for how you subtract two boxes of numbers? You might wonder. You might be thinking. I would have been back when I was a pre-calc student. If I hadn't seen different things, I would have said, "What do you mean? There's only one way to do it." No, there's all kinds of. Let me give you, for example, you could say, "Hey, here's the way. You add all those numbers up first." This is not the right way, but you might have said, "Hey, yeah, you just add them all up." So what's that? 6, 7, 8 minus 2. This is a 6. And then you subtract. Then you add all these up. 8 minus 2 is 6, and 6 is 12, minus 4. Then you subtract 6, it's 2. There we go. No, that's not what they decided to do. But that is something they could have. They're making it up here. So they could have said, yeah, we'll just add up all the numbers in the boxes and then subtract them. That's not what they decided to do, which is probably not even what was in your mind either. But I just wanted to show you that because wanted to let you know there are different things they could have done. So what would you do if you were in charge of making the rule for how you subtract two big boxes of numbers?
I have each overlapping box subtract.
Do what's that?
Each overlapping box subtract from the other.
Yeah, right. How do you say it? Yeah, totally. Yeah, however you say that. Corresponding, that's the word. Corresponding entry with corresponding entry. Upper left with upper left. Upper right with upper right. Exactly. That's the real rule. That's exactly what they did too. So 0 take away 8 is negative 8, huh? Just go entry by entry. And 3 take away 1 is 2. Negative 2 take away 0 is negative 2. So they just go entry by entry. 1 take away, careful, take away negative 2. What's that? 1 take away negative 2 is like that, huh? So that's going to be 1 plus 2. It's going to be 3 right here, isn't it? That makes sense. And I'll show you, by the way, how to do all this in your calculator in a minute. But these simple ones probably easier just to do by hand. It takes so long just to enter them in your calculator. You might as well just do it by hand. So keep going. Just go entry by entry. 3 minus 5, what's that? Negative 2. 1 minus negative 8. That's 1 plus 8. 9. Like that. And there we go. There's the answer. So they just go entry by entry. That's the rules they made up.
Oh dear.
Pretty easy, right? Good so far? A little different. There we go. So 5 times b. See what they have here? I don't know if you can read that. It says 5b. So they want me to take matrix B. We're not even using A. They might as well not have even given me A. It has nothing to do with A, huh? They just want me to take matrix B, and they want me to multiply it by 5. Well, how do you multiply matrix B by 5, do you think? How do you take like a whole number and multiply matrix B? Do you think you just multiply like just the first entry, the upper left? No, that's not what you're thinking, huh? You're thinking you multiply all of them, and you're totally right. That's exactly how they made it up. You just distribute, totally. That's exactly what they said. They say, well, if you have a number in the front, like a 5, it just goes boom, 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 boom. Just hits everybody. So that'll be, what? 10 and 5 and 0 and, what is that? 5 times -2? -10 and 30 and -20. And there it is. Can you read that? Just multiply all of them by 5, huh? Pretty natural, exactly what you would expect, right? So far, so good. Something you wouldn't expect is coming. But so far, so natural, right? All right, you want to try that one? So it's 5 times matrix A minus 2 times matrix B. Is that good? So you can find the 5A matrix first off if you want. You can do it all at once or take it in smaller pieces, whatever you like. I'm probably going to do it real slow here. And then I'll find the 2B matrix, and then I'll subtract them. Whichever way, let me give you a second. Go ahead and try whichever way. All right, you're doing okay. So 5 times A. So I'm going to go 5 times this matrix, be 0, 15, -10. And then the other matrix is 2 times B, huh? So it'd be 12, 2, 0, -8, 10, -2. And then we have to subtract them. So the answer, so it'd be 0 minus 12 be -12. 15 minus 2 be 13. -10 minus 0 is -10. 5 minus -8, add 8, what's that, 13? 5 minus 10 is -5. 5 minus -2 plus 2 is 7. Did you get that okay? Is that making sense there? Anything I can answer on that? All good? All right, I'm going to move on then. So what are we doing with B and C there? We're multiplying, huh? It's B times C. It's matrix B times matrix C. So we're taking this matrix times that. We're not even using A. I don't even know why they even have A there. So we're just taking matrix B times matrix C. We're just going to multiply those two matrices. And notice the answer is yeah, it's only got 4 numbers, huh? How can all those B, C numbers only result in 4 numbers in the answer? This is kind of strange looking. Has anybody multiplied matrices? Or I'm probably a lot of you have. Anybody remember how to multiply matrices? What's that?
Rows times columns.
Rows times columns. Exactly, yeah. First off, it's important to talk about the size of the matrix. So let's talk about the size of a matrix before we get to the actual mechanics of multiplying, because the size is how we'll set up the multiplying. So what do I mean the size? Well, you always go down by a cross. Always down by a cross. So how many how far down, matrix B is 2 rows down, huh? By 3 rows across. It's a 2 by 3. That order matters. What I'm saying is you say 2 by 3, you don't say 3 by 2. That will become real important in what we're about to do is to make sure you go down first. Now, they made that up like they made up everything else in math. They could have went across first, you know. Like we could drive on the left side of the road. They do in Europe. But we have made up a rule that in North America, we're going to drive on the right side of the road. Same thing, they said, hey, we're going to go down first when we give the size of a matrix, which is kind of weird. Graphing, we always go across first, don't we? And then we go up and down. But matrices, they always go down first when they're giving you the size of the matrix. It's real important because that'll matter. So down 2 over 3. So what about the size of, so that was B. What about the size of matrix C? Down 3 over 2. It's a 3 by 2, isn't it? So matrix B is a 2 by 3 and matrix C is a 3 by 2. Okay, so what does that mean? Well, here's the rule. Does anybody know? What do you do about the sizes when you multiply matrices? The inside numbers, these two right here, that are inside, it's a 2 by 3 and a 3 by 2. These inside, the numbers inside, must be equal. Must be equal. Those two numbers must be equal, or you can't multiply the matrices at all. They have to be equal. It's kind of like it's a green light. Now you can go, so to speak. If those two inside numbers are different, that's why the order matters so much, you know, which one's first or second, because the placement matters. If the inside numbers were different, it's a red light. You can't even multiply these matrices at all. But if the inside numbers are the same, then it's a green light. You are allowed to multiply these matrices. Okay, great, I'm allowed. How do I do it? Well, first off, you got to set up the answer. The answer size will be the outside numbers, which in this case is 2 by 2. That's why the answer matrix they're setting up is a 2 by 2, because they know the answer's going to be a 2 by 2. Is that making sense? So the inside numbers have to be equal, then you can do it. Outside numbers tell you the size of the answer matrix, 2 by 2. So the answer to B times C is going to be a 2 by 2. Okay, great, it's going to be a 2 by 2, but how do I actually find it? Well, now we do, like a weird thing here. Let me show you. In fact, I'm going to go to a fresh screen if I can, because we need lots of room. You guys got all that copied down? So, all right, so how do we actually do it? So I'm going to make a big matrix here with lots of room. You want to make something with lots of room on your paper there, because even though there's only 4 numbers, these 4 numbers come from lots of calculation. So leave 4 big blanks like that. That's going to be the answer matrix, 2 by 2 answer matrix. And by the way, I'm going to show you by hand, but then we'll also do it by calculator. So you don't need to be like overly alarmed if you're not totally catching the by hand. We'll do it by calculator in a minute too, and that's fine with me on the test, just to crank it by calculator. You know, graphing calculator. We'll do these also. So here, because it's kind of weird. So here we go. Now, by the way, if you or I were to make it up, wouldn't we just do it like we did adding? Just go like entry by entry, upper left times upper left, and that's what I would think. I think that's what most people would think. But they didn't do that at all. They made up something totally bizarre with how they multiply numbers. What they said is take the first matrix and always go across on the first matrix. And take the second matrix and always go down. So, and then every time you multiply, well, I can't do it. You multiply and you jump. And you multiply and you jump. And you multiply and you jump. So in other words, it's going to be 3 times 5. I'll write it all right here for you. 3 times 5. Plus, and then everybody jumps. Jumps where? Well, this one's moving across, so it'll jump to the 1. And this one's moving down, so it'll jump to the 5. And now it's 1 times 5. See what I'm doing there? It's kind of weird, huh? It's like your left hand is going across and your right hand's going down. Like that. That's what's happening. So the left always goes across, the right always goes down. So now you jump again. What's the next? You'll keep going across. 0. Keep going down. -3. So plus 0 times -3. That is, whatever that adds up to be, that is the upper left corner. That's the first entry. What is that? 15, 5 is 20, plus 0, so it's 20. So that's what goes in that box right there, 20. We're 1/4 of the way there. That's weird, huh? Now, so now that was the upper left. Let's erase what we did here. Now you shift. How do you shift? Well, I'm I'm going to keep going across, and now I'm going to move to this column. Right, last time I was over here. Notice where I'm at. I'm in the upper row, right column. I'm here, upper right, aren't I? Whatever happens is going to go up here, because I'm in the upper, not the lower. I'm in the right, not the left. I'm in the upper right. Again, your left hand always goes across, your right hand always goes down, always, for matrices. So here we go. 3 times 1. Everybody jumps. 1 times 2. Plus, everybody jumps. 0 times 1. What is that? 3 plus 2, 5. There's the upper right. Is that good so far? Pretty weird, huh? Now, we're done with the upper. Now, we redo all this with the lower left. So I'll go lower left column. Again, my left hand goes across, my right hand goes down. Here we go. Negative 4 times 5. Plus, everybody jumps. 4 times 5. Those will cancel. Plus, everybody jumps. Was that, is that negative 5? Yeah, negative 5 times negative 3. So that's just positive 15, isn't it? All right, one more. That was the lower left. Finally, lower right. Here we go. Negative 4 times 1. Plus 4 times 2. Plus negative 5 times 1. So what is that? Negative 4 plus 8 is 4. Negative 1? Oh, that's new. Negative 1. And we're done. It's just that easy. I'm kidding. That's not easy. That's painful. Is that good on that? Does that make sense? Pretty weird, huh? When I first saw this, I thought, why? Like, why did they make up such a wacky way to multiply numbers? And the answer is the same reason everything they made up in math. It turns out to be actually very useful for real life things this way. And I think we'll see a couple. Maybe not. We're just touching this and moving quick. If you go to higher math, you see what they do with matrices, and this is actually a good way to do it. There's things in real life that this is useful for. Anyway, we good there? Let's try another one. How about? Okay, so they want you to multiply C times A. By the way, the order matters. C times A is not the same as A times C, which is weird. We're not used to that either. That's a different quality in the matrix world. So first thing you want to do when you're doing a matrix like C times A is you want to do this. You want to do C and A, and you want to write the size of the matrices down below. So what's the size of matrix C? Yeah, you always go down first by a cross. Yeah, totally. So it's C is down 3 over 2, huh? 3 by 2. And what's the size of matrix A? Down 2 over 3. 2 by 3. See how the inside numbers match? They're equal, so that's a green light. We can multiply matrix C times matrix A. And what will the size of the answer matrix be? The two outside numbers, 3 by 3. That's why they have a 3 by 3. Now you might say, I didn't do that. I knew it was 3 by 3. They gave it right there. Well, in a minute they're going to give you, they're going to have an option that says can't be done. And then on the multiple choice exam, there'll be all kinds of different options. And so you'll need to be able to figure this out for yourself. So does everybody see what I'm doing there? By the way, this brings up an interesting question. Could I multiply A times C? Could I reverse the order? Would that be okay? We're going to do C times A. C's coming first. But could I reverse it? Let me ask that question. Could I? Well, A is what size? 2 by 3. And C is what size? 3 by 2. The insides match, so it would be a 2 by 2. The answer would be a 2 by 2, wouldn't it? Totally different size, even. See how reversing the order makes the whole answer totally different? We're not used to that, are we? That doesn't happen with the normal real number system. That happens in the matrix world. The order matters in which you multiply matrices. All right, so anyway, let's do this one. So we know the answer is going to be 3 by 3. Let me go to a fresh screen. Can you crank it? So what I would probably do, guys, is I would do matrix A right over here to the right of matrix C, because we're going C times A. So it's just nice to have it on the right. And then remember how it works. Your left hand goes across, your right hand always goes down. C times A. So we're going to have 9 answers. Leave yourself some space. Three by 3 answer matrix. So your left hand goes across, your right hand goes down. So here we go. Want me to do the first one with you? 4 times 0 plus, and then everybody jumps. How do they jump? The left hand always goes across, the right hand always goes 1 times 1. So that's 1. Everybody see what I did there? And now jump to the right one. And we'll jump to the right one. And do it again. Want to try that? I'll give you a minute. Instead of me just cranking it out. See if you can do some more there. Give you just a second. So is that okay, though? Does everybody see exactly what I did there as I walked through that? That making sense on all that? All right. So yeah, let's. Okay. So let me show on the graphing calculator. So first thing you've got to do is hit second matrix. Yeah. So hit second. See the? Oh, you're not. You can't see it, huh? Switch back and forth. They're on the left side of your calculator, at least on the TI. Now I'm only showing the TI. I'm glad to help you with the Casio or whatever else you got. Going to have to be office hours, just because the majority of you have TIs. So I'm going to just do what the majority has. But I'm glad to help you, and I'll send some instructions. I'll send some instructions to your email, whatever email you put into YouTube. Into Math Excel. I'll send you some instructions that I find. I'll go onto YouTube and find something. So anyway, so on the TI anyway, second matrix. See matrix right there on the left side? So hit second matrix, and it goes into matrix mode. So that's for entering. So there's 3 menus. The names, there's the names, and then there's math, and then there's edit. So basically, we want to go over to edit. So use your arrow and go over to the edit menu. It's kind of like entering a Microsoft Word document or something, right? You go into entering it, you enter it all, and then the thing saves it. That's kind of what we're going to do first off is we're going to type in the 2 matrices. Our calculator will save them, and then we'll switch over to the menus where we tell it to do stuff with those matrices that it now has saved. So first off, go to the edit menu, and we're going, and then hit, and then see how I'm on edit, and I'm on matrix 1. You can move down. We don't really want to, but see how that moves down? I want to stay up there at 1. Edit matrix 1 or A. Edit matrix A. Hit enter. Enter. It's now saying, okay, I'll let you input matrix A. I have some old matrix I put in there. I'll type the new one over the top of it. So, all right, so let me go back and write the instructions as we're, well, here, let's just type it in. So now it's asking for the size of matrix A. What's the size of matrix A? Oh, wait, I don't want matrix A. I want B and C, huh? Oh, yeah, let's quit this. Let's go back and put in B and C. I'm going to go quit, second, quit. Everybody see what I did there? Go back into matrix mode again. Second, matrix, back into, let's go over to edit and down to B. I forgot we're entering, oh, no, we are entering A. I'm sorry. I'm totally confused. Let's go back. Let's put in matrix A. There is a matrix. I thought it was B and C. It's C and A. All right. Let's go back. We're going to put in matrix A again. All right. What size is matrix A? It's a 2 by 3, isn't it? 2 down, 3 across. So hit 2, enter, 3, enter. And it sets up a 2 by 3 array for you. Type in the numbers. Just hit enter every time. 0, 6, negative 1. 1, 2, 4. That is matrix A right there. See how I entered it? Make sure you use the negative and not the subtraction. Remember, the calculator gets all bent out of shape with the wrong kind of negative. It's not very user-friendly about that. So just do every entry and hit enter. Enter each time. So there's matrix A. Everybody got it? Everybody good there? When you're done with it, it's got, every time you hit enter, it saves it, saves it, saves it. So it's got it. I could just turn off the calculator right now. It's got it saved. So I'm just going to hit second quit to go out of this mode, wherever quit, up here. Second quit. It's got it. It's got matrix A saved. When I call up matrix A in a minute to multiply it, it knows it. It's got it. Every time you hit the enter key, it saves right then. So now, enter matrix C. Can you do that? Go back into the matrix mode, put in matrix C. I'm going to write out some of these steps on the thing here. So hit second matrix. This is on the TI. Second matrix, and then go across twice to the edit mode. Hit enter. Type in size 2 by 3 for matrix A, and input the entries. Then hit second quit, and same for matrix C, and hit second quit. So put in matrix C now. So step 1, step 2, put in matrix C. So we'll go back to the thing. So I'm going to hit second matrix, over to edit, down to C, right? So I go over to edit and down to C. Hit enter. C is a 3 by 2. 3 by 2. Sets that up for me. 4, 1, 6, 3, negative 5, 3. So it's got it. There's matrix C. Good. Every time I hit enter, it saves it. So it's got it all. I just hit second quit. So now, what do we do at this point? Now that we have matrix A and C stored in our memory banks, go back into matrix again, hit second matrix. Good so far. And now what you're going to do is you're going to call them forth, almost like a magic spell or something. You're going to conjure up the matrices onto the main screen. It's got them in its memory banks. You're going to say, calculator, go get that thing and bring it to the main screen for me. So you're going to say, first off, we're going to start with C, right? The order matters. So we're doing C times A. So you got to go. So notice I'm on names. I'm not over on edit. I'm not over here at the edit menu. I'm over here in the name menu because I'm naming it. I'm conjuring it forward. Saying, I name matrix C. Come on forward. So I'm naming matrix C. Hit enter. When you have names in C, enter. Boom. It just puts C. It knows what it is. It's got it in its memory banks on the main screen. And I go times, just the normal times button. And then go second matrix again. We're going to the magic spell and calling up, this time, matrix A. Name A. Enter. C times A is on our main screen. Hit enter. There it is. There's the answer we got. Hopefully the right answer. Let's see. Get the right answer. 126.0, 342.6, 3 negative 24.17. Done much more easily than we did it. Just like that. Is that good? Is that making sense on that? So let me write down those steps. What was it? It was second matrix. So step 3 was second matrix. And then, what did I do? Second matrix. Oh, and names. So just I went down to C on names and hit enter. And then times on main screen. Well, hit the multiply on main screen and then second matrix A, enter. So there we go. So there's the steps. Second matrix down to C, enter, multiply on the main screen, second matrix A, enter. And we multiply the matrices. Can you read all that? It's a little second matrix A, enter. You can hopefully read that there. Is that good questions on that? All is well? Putting that into your calculator? All right. If you got that down, I'm going to keep on moving. So you can just do those in your calculator. In the real number system, so we're making up a new world here. A new world of things called matrices, right? Boxes with numbers in them. And there's rules for this new world. There's how you add these new creations, how you subtract them, multiply them, divide them, all that kind of stuff. If you major in math, after like your senior year, you do stuff like this where you prove how made up systems work together. That's kind of like what we're doing here. We're making up a new world called matrices, and they have different kinds of rules. For example, in the normal real numbers, 1 has a certain special function. I don't know if you ever thought it's just 1. What are you talking about? Well, he's technically called the identity element. What does that mean? Anything times 1 gives you back identically what you multiplied by 1. 1 plays the role of the identity element. We call it every system has to have it doesn't have to, but they almost always have an identity element. Well, in the matrix world, what matrix plays the role of 1? What acts like a big 1 in the matrix world? What matrix, what A, if I just took this A or whatever it is, times what matrix would just give you back A? That's the whatever matrix that is, that's the 1, the identity element in the matrix world. So that's the question. Who's the identity element? Who's the big 1? Is it just 1s everywhere? Is that what it is? What size is it? Well, you're thinking, well, no. Tell us, Mr. Aaron. Yeah, exactly. Well, that's what the I2 and the I different stuff is. It turns out it's not 1s everywhere. That will not give you back A itself. What it is it's 1s down the diagonal and 0s everywhere else. That's the big 1 in the matrix world. If you multiply by that kind of a matrix, you always get back yourself. That always, if the sizes work, that is. If the sizes are right, if you multiply by 1s down the diagonal, 0s everywhere else, it gives you back what you started with. It's the big 1. It's the identity element in the matrix world. So that's what they're meaning by I2. So what is I2? It's the identity, I stands for identity. It's the identity element for 2 by 2, meaning it's a 2 by 2 with 1s down the diagonal, 0s everywhere else. What would be I3? You get it, right? This was I3. It's a 3 by 3, again, 1s down the diagonal, 0s everywhere else. I4, I5, I6. So there's a bunch of 1s, actually. There's a bunch of 1s for all the different sizes. Those are the identity elements in the matrix world. They play the role of 1. They do what 1 does in the real number system. So you learn, that's how systems work together. So anyway, so what do they want me to do here? I would just do all this in your calculator. When they say I2, just type that in. Call it matrix C. Call it whatever you want. Does that make sense? I would just say matrix C, and I would just put in 1001, and I would type into my calculator matrix A and matrix B, and then I would just do A times B plus 2 times C. I'm calling I2C now. 2 times C, and you're done. Is that good? Is that okay that I just say that? Like that? Just call it C, type it into your calculator, and do the whole matrix thing in your calculator. All right, that's all that's required. Because you can eliminate some of the answer options just by the size thing. So what size is this first matrix? Remember, it's down first. It's always down, then across. That order really matters. 2 by 3. And then what size is this one? 3 by 2. So the inside match, so that's a green light, go. You can do it. What's the size of the answer? 2 by 2. So no way, no way, no way. It's either A, B, or D, huh? It's one of those 2 by 2s on that. And you do the rest in your calculator. So far in the matrix, we're trying to learn all the operations, add, subtract, multiply, and divide, with matrices, right? So far, we've added, subtracted, and multiplied matrices. How do you divide them? How do you divide them? Well, dividing is really upside down multiplying, isn't it? Do you ever think about the way the operations are related to one another? Right? Dividing's not really something brand spanking new. It's just upside down multiplying. In other words, it's inverse multiplying. In other words, 4 divided by 2 is really 4 times a half, isn't it? Same thing. It's 2 either way, right? Dividing is multiplying by the inverse. The multiplicative inverse, we call it. You know, the 2, the inverse of 2, the multiplicative inverse is a half. Right? So dividing by 2 is the same as multiplying by 2's inverse. Well, so in other words, I'm saying dividing is multiplying by the inverse. So if we want to learn how to divide matrices, really what we want to learn is how to multiply by the inverse of a matrix. That will be dividing. So to do that, we got to find out what is the inverse of a matrix. What is the inverse? In other words, and what does it mean to be an inverse? Do you ever stay up late at night thinking about that? What does it mean to be an inverse? Of course not. That's what weird math teachers do, right? And actually, I didn't either until they made me do that my senior year in my math degree. They forced me. So then I had to think, okay, what is an inverse really? What does it really mean to be an inverse? Well, 2 and a half, 2 and 1/2 are inverses because if you times them together, what do you get? The identity element, 1. 2 things are inverses. If you multiply them, you get back to 1. That's what it means to be an inverse. The thing that brings you back to 1. That's the inverse, huh? So when I ask, what's the inverse of this matrix? I'm really asking, what matrix can I put here? And I'll get back the big 1. And what is the big 1? We already decided. It's 1s down the diagonal, 0s everywhere else. So we're really asking, this matrix times what will be the big 1? Whatever that is, that's the inverse, isn't it? That will be the inverse. Do you see how that works? See the thinking there? Logically about how systems work together and what it means to be an inverse, and what it means to be a unity element. So if you want to get a math degree, this is the kind of stuff you do in your senior year, but it's all letters because it's made up systems. Anyway, so let me just quit beating around the bush and give you the rule. What I'll do is I'll give you the by hand rule, and then we'll do it on our calculator too. So let me just go to a fresh screen. The by hand rule is a little bit weird. It is this. If you start with a matrix A, B, C, D, the inverse, here's what it is. And I'm just giving you the rule for a 2 by 2. The inverse is you switch the main diagonal. You switch the A and the D. You put D here and A there. Switch the position of those two. You change the sign on the other two, minus B and minus C. By the way, did you hear the way I said that? You want it, as you're moving up the line in math now, going to calculus next maybe, you want to, when I say like negative C, I said change the sign. That's what it really means. It's not necessarily negative because I don't know what C is, right? If C itself is like negative 3 or something, then that's negative 3. That's actually positive, isn't it? Do you know what I mean? So when you put a negative on a letter, it doesn't mean the thing's negative in the end. It means the thing is the opposite of what it used to be. So you want to think that way about negative signs, or you'll be very confused when they're doing things with negative signs as you move up the line in math. Negative on a letter doesn't mean negative in the end. It means reversal of sign, doesn't it? So you want to think that way. So so I say reverse the sign on these two. So switch the order on the other two, reverse the sign on those two, and then divide all 4 by something called the determinant. The determinant of a matrix, you don't have to know that name. But what it is it's A times D minus B times C. It's a number. That turns out to actually be a number. So you divide all 4 by that. I need a little more room to write that in. I'm just going to call that, what am I going to call that? I'm going to call that number. And just divide all 4 of those by that number. And you're done. That's the inverse. So that's how you find the inverse of a 2 by 2. You switch the order on the main diagonal. You change the signs on the other diagonal. You divide them all 4 by number being the determinant AD minus BC. All right, should we do it? Theory is one thing, but actually doing it's another. So let's actually do it. Let's determine Let's do the determinant right now. This is A, B, C, D, right? 7 times 1, A times D, minus B times C, 1 times 1. It's main diagonal. You guys understand what I mean by that word main? Right, there's 2 diagonals, aren't there? When I say main, I mean the one that starts with the upper left. The first entry in the matrix. That's the main diagonal. So main diagonal, that's A times D, minus B times C, 7 times 1, minus 1 times 1. That's 7 minus 1, that's 6. So that's what I'm going to divide all 4 by. But what do I do first up? So you draw the matrix, you switch 7 to 1, put 1 here, 7 there, and you change the sign on the other 2, -1, -1, and then you divide all 4 by 6. There it is. That's the inverse matrix. That's the inverse of our original matrix. If you multiplied our original times that on your calculator, you would get the big 1. The 1's down the diagonal, 0's everywhere else. That's the inverse. Does that make sense? We'll do calculator in a minute. Let's just make sure you got the by hand first. All right. Let's try one of these. Okay, so 9, 8, 3, 3. So try finding the inverse of that one. So start by finding that determinant. You know the number? Multiply the main diagonal minus the other one. So the determinant, the number, is 9 times 3, main diagonal, minus other diagonal. So it's at 27 minus 24, 3. So I'm going to divide them all by 3 after I move them around and stuff. So the inverse is going to be, swap the main diagonal. 3 goes here, 9 goes there. Change the sign on the other diagonal. And then divide all 4 of them by 3, the determinant. And then you got to reduce some of those. Those need to be, the other one didn't need to reduce, this one does, huh? So that'll equal what? So 1, -8 thirds, -1, 3. And there we go. Is that okay? Finding the inverse of a 2 by 2. So that's the inverse. So if you multiply that, it's like dividing by the original. Make sense? It's like multiplying by a half, which is the same as dividing by 2. That's how we're going to divide in the matrix world. We'll multiply by the inverses. Good? So 3 by 3 inverses only on the graphing calculator. Do not do. I'll show you what they say to do in a minute. I'll do the show me example. It's horrific. You don't want to do it. 3 by 3 inverses only on the graphing calculator. Not ever, never, not ever by hand. I will not make you do it by hand. Ignore the show me an example. They do something crazy hard. Well, because they're showing you how to do it by hand. Ignore the show me an example. I will not make you do it that way. I will not make you do any 3 by 3s by hand. So, okay, so just put it in your calculator. So it's just second matrix, like usual. And go across to edit. You can just put it in matrix A if you want. Edit. And then enter the matrix. 1, -1, 1, 0, -2, 1, -4, -5, 0. And then second quit. So that's step 1. Put it in. Step 2, go back to second matrix again. And this time, you're going to go to names and hit enter. You're going to call forth matrix A. So put that into matrix A, call it forth, and onto the main screen. And then you have an inverse button, which is somewhere I can't see. Everybody see it? Little x to the -1 button. Is it above something or?
It's right
Oh,
on the
it's the matrix button. Yeah.
Is it matrix?
It's the matrix button. Yeah. So second matrix, call forth the matrix A on the main screen. The main screen you'll have matrix A, or is it put in a box? Puts it in a box or something. And then hit the X to the -1 button, which is the matrix button, and hit enter. That's it. It does the inverse for you. So I'll do it on the thing here. So go to matrix, go over to edit, matrix A. This is a 3x3, and 1, -1, 1, 0, -2, 1, -4, -5, 0. So put it in, second quit, second matrix again, name it, call it forth, and hit, and then at this point I'm going to hit this X to the -1 button, right? Which is the matrix button on the TI anyway. So matrix A to the inverse, enter, there it is. There is the inverse matrix. So I'm getting, it's right there, 5, -5, 1. So 5, -5, 1. -4, 4, -1. -1. -8. 9. -2. Good? All is well. There's the inverse matrix. Sometimes, by the way, if it comes out to be a bunch of decimals, I should say, yeah, let me mention this. Well, let me do one in a minute. I'll just tell you, if it comes out to be, if it's decimals, do you remember what you can do on the TI? You hit math, the math button, enter, enter. And that just changes the whole thing to fractions for you, which is how Math Excel wants it entered. So if it comes out decimals, just hit math, enter, enter. It'll make the whole fraction into fractions for you. Oh, I'm not writing on the screen. There we go. So, there. So if it's decimals, here's where I wrote that. If it's decimals, hit math, enter, enter. This one didn't. This one came out to be nice whole numbers. I didn't get any decimals, so it wasn't a problem. But if it does, if it comes out to be decimals, which some of them will, hit math, enter, enter at the end, and it'll make it all into fractions. At least that's how the TI does it. Casio's even better usually and cheaper. So I'll send you Casio instructions, or come see me. I'd be glad to help. Yeah, let's do this one real quick. Since it's I want to show you how to do the fraction. So put that one in your calculator. Second matrix, that whole thing. Matrix A, 3x3, 1, 1, 1, 3, 2, -1, 4, 1, -1. So quit. Second matrix, call it forth. Inverse. Yeah, good, thank you. I'm getting awful. I'm getting like, what came up on my screen when I did the inverse, I'm getting 0.142857, 0.142857, blah, blah, blah. I'm getting like lots of decimals. Like that. You guys getting that? Getting like a big mess like that? So what do? Math, enter, enter. So see the math button here? Hit math. Math, which brings up the math menu. See the first option says change to fraction. That's what we want to do. Change to fraction. Enter. It says, you want me to take that answer and change it to a fraction? We go, yes, please. Enter one more time. There it is. So there's the matrix put in nice form for us. So the inverse, I mean. So it's 1/7 minus 2/7, 3/7, and then 1/7. Next row is 1/7, 5/7 minus 4/7. The bottom row is 5/7. Bottom row is 5/7 minus 3/7, 1/7. And you can always, you see how it's off the screen, dot, 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 you can use your right arrow. There's nothing over there, just the brackets on the right. But if you ever need to move, you use the arrows. Is that okay? We good with that? So I'll move along. All right. So there's the inverse. There's how. Okay. So now we have three equations with three letters. Everybody see that? We did these by hand earlier, right? But not one that hard. Look at that one.
Crazy.
That one looks awful. And the answers are all going to be decimals. We don't want to do this one by hand. We want to use our calculator. Now, how do you use a calculator to solve three equations, three unknowns? Well, let me show you the steps. Basically, you transform that whole thing into a big matrix equation. Here's the beauty and the power of the matrix world. Let me show you. You take the big matrix that's just the numbers. You just peel off the numbers. 24, 59, minus 12, 16, minus 10, 6, 3, 4, negative 1. Just peel off the numbers. See, there's no letters there. I just took the numbers without the X, Y, and Z. You put next to it, in one big long column, X, Y, Z. Why? Because if you multiplied this, it would be that. Exactly. I'm not going to do it. Let me prove to you it would be. Don't do it. You don't need to do it. I'm just saying that's true. It's always right. What? What's the size of this matrix? 3 by 3. What's the size of this matrix? 3 by 1, right? 3 down, 1 across. Inside numbers match. Green light, go. What's the size of the answer matrix? 3 by 1. The answer is 3 by 1. So what will be that 3 by 1? Well, you go across here and go down here. So what's going to happen? 24 times x. 24 times x. Go down. Go across. 59 times y. 59. See? It's cranking out the same thing. Do you see that? See how it's producing exactly what we've got? It's just another way of writing it. So again, you don't have to do that. You don't have to do any of this. I'm just proving to you it's true. It's right. So I just took the whole, and what do you do with the right side? The right side, make it into one big matrix. 23, 1, 2. So you see what I've done? I've transformed three separate equations with three letters into one big matrix equation, haven't I? It's the same thing. If you multiply that left side, it's the same equation. But it's made into matrices now. Now, why do I want to do that? Well, now, you know what this is like? This is like, let me help you think in analogy to the real number system. This is like having a number like 7. This is like, you don't have to write this down, but this is like 7 times x equals 4, or whatever. So I want you to think that way. This is like a number in the matrix world. This is a letter in the matrix. It's a matrix letter, and this is like a number, right? So what would you do with 7 times x equals 4? How would you solve for x? That's what we're trying to do, right? Solve for x. How would you solve this little simple equation, 7 times x equals 4, what would you do? You'd divide by 7, right? You'd divide by 7. Now, how do we do divide in the matrix world? We multiply by the inverse. That's what dividing really is. So in other words, you'd multiply by 1/7. Same thing, huh? And multiply by 1/7. Same thing, right? And that would take care of it. Except, notice, remember, when you have an equation, you're supposed to do the same thing to both sides. They're equal before, treat them the same, still be equal, right? I'm multiplying by 1/7 on the left of the left side. And I'm multiplying it on the right. That's different. Now, we know for real numbers, who cares? It makes no difference at all. But for matrices, it matters. So you have to multiply it on the left on both. Because the order matters in which you multiply matrices. Did you follow that? Right? So you multiply by 1/7 on the left of both. That way you're doing equal treatment, truly equal treatment. These will cancel, you'll get x alone, and there's your answer. Well, that's exactly what we're going to do now in the matrix world. Well, what do I mean? How do you do that? Well, I'm going to take this guy, and let me just say his inverse times him on the left, and the inverse, that same inverse, right here on the left, times that one. I'm going to multiply by the 1/7 on the left of both. And what will that do? Cancel this out, and we'll have x, y, z alone equals, and we'll have some answer over here. It's just like solving a real number equation, except it's a matrix equation. Do you see that idea? Did I lose you there? Do you see what happened? Just like I had, 7 times x equals 4, and I need a little room there. 7 times x equals 4. And I said, well, the way to handle this is to multiply by 1/7 on the left here and 1/7 on the left there. It'll cancel this out, and you'll just have x. Because that's what an inverse and the thing do. It's just 1. It's just 1 times x is just x. Well, that's what I'm doing. Inverse on the left, and the inverse times this will cancel out. Just like these guys cancel out, right? It's what an inverse does when you hit its normal state. Inverse and normal, gonzo, right? These will cancel. And then you also do the inverse on the left here, and inverse times this will be the answer, won't it? So long story short, what do we need to get the actual answer, which is where? The right side. To get the actual answer, the answer is going to be the inverse times the 23, 1, 2 matrix, isn't it? You tracking with me? That's all you need to do. That was all theory leading up to this conclusion. In the end, all you need to do is take that original matrix they gave you, type it into your calculator, and find the inverse, and multiply the inverse times that one. So call this matrix A, and do A inverse times B. So let's do it. You know what I'm saying? I'm saying let matrix A be the original one, the 24, 59, minus 12, 16, minus 10, 6, 3, 4, minus 1. Let that be matrix A. Let matrix B be the 23, 1, 12, 23, 1, 2 column matrix, up and down. And your answer is going to be A inverse, right, the inverse, A inverse times B. And boom, you'll have all three answers, A, B, and C. You will solve the 3 by 3 that quick. The power of matrices. So A inverse times B will be your answer. Let's do it. So go to matrix, edit. I'm going over to edit. Input matrix A. What's matrix A? It's a 3 by 3. 24, whoops, I blew that. 24, 59, negative 12, 16, negative 10, and 6, and 3, 4, negative 1. Okay, so I've got matrix A in there. We good? Second quit. Go back to matrix, edit B. Now I need matrix B. You edit B, go down to B. Edit B, enter B. What's B? It's a 3 by 1. It's a column matrix. 23, 1, 2. Everybody good? I got matrix B put in there. A and B. Quit. And now column forth, right? Matrix, name it. A. Come forth. Enter. There's matrix A. Inverse button. A inverse times. And then go back to matrix and call forth B. A inverse times B. Enter. Those decimals, that's X, Y, and Z. However far they want you to round. Hundreds. Just round them to 2 places. And so the answer I'm getting, rounded to 2 places, is 0.29. 0.29. And 0.23. And negative 0.23 for Z. This is X, Y, and Z. We just solved a 3 by 3 equation that quick using matrices. So it's things like this that give matrices their usefulness to us. Is that good there? Guys got that answer now? We got a couple minutes. I want to make sure I cover these last. I can't imagine what else is left. All right, so this one on your calculator, do you realize it's going to be 1, negative 2, 4, negative 3, 5, negative, negative 3, 5, negative 2, and 5, negative 2, 0. Do you see how the Z is missing? The Z is 0 right here. I just want to make sure you're aware of that. Inverse times the one on the right. 127 minus 25. Hit the buttons on your calculator, right? You just take the inverse of the main times the one on the right, and you'll get the answer there. Not good on that? That'll be easy. Now, one of them will tell you, it will say, when you do it, it'll say singular, or no, not non, it'll say singular. Singular matrix. That's a way of saying no inverse and no solution. So it'll say singular matrix. Your calculator, when you type it in, hit inverse, it'll go eh. It won't go eh, but it'll say singular matrix. And so, all right, guys, you're going to have to work on